is 0 means the wave function will not change its sign. What is a node? Node is a plane where wave function changes its sign. That is a node. Now in this particular molecular orbital psi1, there is no node, means there is no plane in which the wave function changes its sign. That is, whatever the lobes which are placed at the top will be at the top only. Whatever the lobes which are placed at the bottom, they will occupy at the bottom only. That is the meaning of no node. Right? So that is all the top. So there is no need of any ambiguity over here. So first of all, label the upper lobes. Now if you are labeling the upper lobes, automatically we can label the lower lobe. If upper lobe is positive, then lower lobe is negative. If upper lobe is negative, then lower lobe is positive, and vice versa, right? So there is no node means all the upper lobes are in the top phase, all the down lobes are at the bottom phase. So all the upper lobes are at the top phase, and top phase means they are represented by positive sign. They are represented by positive sign. They are represented by positive sign. And all the bottom lobes are represented by negative sign. All the bottom lobes are represented by negative sign. Because in this, the number of node is 0. So the overlapping is maximum. All the lobes which are there at the top phase are in the top phase only. And all the lobes which are at the bottom phase are in the bottom phase only. So the overlapping is maximum. And maximum is the overlapping. Maximum is the overlapping, greater is the stability. So that's the reason psi1 molecular orbital is associated with the maximum amount of stability. And one other reason why the psi1 is more stable is bonding molecular orbital. And already I have discussed the bonding molecular orbital is more stable than anti-bonding molecular orbital. Right. So coming to psi2 and psi3. So as we move up, what is happening? Energy is increasing, right? So as we are moving up, energy is increasing means what? What will happen to the number of nodes? Number of nodes will increase. Now the number of nodes for the first energy level. First energy level means this is occupying the lowest energy level. With respect to this first energy level, molecular orbitals are psi2 and psi3. Psi2 and psi3. Now let us say that this is the one possible node. This is one possible node. One possible node. I am not saying that it is the only node. So as we are moving up, what is happening? The nodes are increasing. Now for the lowest molecular orbital, node is 0 means for the next one, the node will be 1. So I am representing that particular node. Now next, another possibility of the node is this. Another possibility of node is this. So number of nodes in the psi2 and psi3 which are occupying next to psi1, which is the lowest molecular orbital, is 1. Node equals to 1. Node equals to 1. Now let us try to project the lobes. So third lobe, fourth lobe, fifth lobe and sixth lobe. Now you have to be very careful over here. If the line is there, if the line is separating the two lobes, then the phase of the two lobes will change. If it is positive, it becomes negative. If it is negative, it becomes positive. Now let us see. First of all, you have to fill the upper lobes. Once you fill the upper lobes, automatically we can fill the lower lobes. If the upper lobe is positive, the lower lobe is negative, and vice versa. So upper lobes I am filling positive. Positive. Right. Now it is in between the line, right? It is in between the line. In between the line means it is in between the node. So line is there. So what happens? The wave function changes its phase. The wave function changes its phase. Positive will become negative now. Now there is no line here. So the negative remains negative. Now there is no node here. There is no node here. The negative remains negative. Now there is a node here in between this. Line is there. Just look at it carefully. Line is there. So the wave function changes its phase. That is, negative becomes positive. Negative becomes positive. Negative becomes positive. Now there is no line. So positive will be remained positive. So now you have filled the upper lobes, right? So definitely the sign of the lower lobes will be exactly reverse to the upper lobes. So once again, positive, it is separated by line, node is there, so it becomes negative. There is no line, means no node. Negative, there is no line, no node. Negative, there is a line, change in the phase. Positive, there is no line, positive. So now we have to place the sign, we have to project the sign of the lower lobes. It is positive. So since the upper lobe is positive, the lower lobe is negative. Right. Since the upper lobe is negative, the lower lobe is positive. Since the upper lobe is negative, the lower lobe is positive. Since the upper lobe is negative, the lower lobe is positive. Since the upper lobe is positive, the lower lobe is negative. Since the upper lobe is positive, the lower lobe is negative. I hope you got it. Right. So coming to this particular molecular orbital psi 2. So these are the degenerate orbitals. Degenerate means the energy associated with both of these orbitals is one and same, because the number of nodes present in both of this is only 1. Right. So now let us place the lobes. 1, 2, 3, 4, 5, 6. So let us place the sign, project the sign of the upper lobes. Positive, there is no line. Positive, there is no line. Positive, there is a line. So node has come into picture. So it becomes negative. Now there is no line. Negative. There is a line. Node has come into picture. Becomes positive. It becomes positive. Right. Now we have placed the sign. We have projected the sign of the upper lobes. Now we have to project the sign of the lower lobes. So since it is positive, the lower lobe is negative. Since it is positive, the lower lobe is negative. Since it is positive, the lower lobe is negative. Since it is negative, the lower lobe is positive. And since the upper lobe is negative, the lower lobe is positive. Since the upper lobe is positive, the lower lobe is negative. It is very simple. It is very simple. Right. It is negative. It is negative. I hope you are getting it, right? Okay. So now, so this is about the bonding molecular orbitals. So we have discussed about the 3 molecular orbitals. The one is occupying the lowest energy level without any node, and the 2 are the degenerate orbitals, molecular orbitals with the 1 node. As we are moving up, what is happening? The energy increases. As the energy increases, as the number of nodes in the molecular orbitals is directly proportional to energy, the number of nodes in the next molecular orbitals will be more than the previous one. So what are the previous molecular orbitals? They are associated with 1 node. Now this will be associated with 2 nodes. This will be associated with 2 nodes. So number of nodes in this are 2. Number of nodes in this are 2. Right? So now let us say, so possible nodes. So this is one of the possible node. This is one of the possible. I will write it in the black only. Possible node. This is one of the possible node, and this is the second possible node. These are the possible nodes only, and do remember that these nodes have not been fixed. It is hypothetical. These are the positive two nodes which are possible in the psi 4, let us say, or psi 5, and these are the lobes which are bisecting. Are the two possible nodes. Now let us try to place. So these are the two possible nodes in psi 5, and these are the two possible nodes in psi 4. Now let us draw the lobes. 1, 2, 3, 4, 5, and 6. So now what we have to do? So based upon the line, we have to project the positive and the negative signs of the lobe. Now it is positive. Let us start with positive. Now line is there in between, so it becomes negative. Now there is no line, it is negative. It is negative. Now there is a line, so the phase will change. It will be positive. Now there is a line, so the phase will change, negative. There is a line, the phase will change, positive. Now we have projected the signs of the upper lobes. Now we have to project the signs of the lower lobes. So since the upper lobe is positive, the lower lobe is negative. Upper lobe is negative, the lower lobe is positive. Upper lobe is negative, the lower lobe is positive. Upper lobe is positive, the lower lobe is negative. Upper lobe is negative, the lower lobe is positive. Upper lobe is positive, the lower lobe is negative. So this is about the one anti-bonding molecular orbital. Right. Now let us try to place the lobes on this particular molecular orbital. On this particular 3, 4, 5, 6. Why 6? 6 carbons are there, so 6 lobes. 6 lobes. Now positive. So there is no line in between, so positive. There is a line in between, so changes its sign, negative. There is a line in between, the sign will change, positive. There is no line in between, so it will be positive. And there is a line in between, it is negative. Okay. Now let us see the number of nodes in the molecular orbital which is occupying the highest energy level. And before that we have to place, we have to project the signs of the lower lobes as well. So upper lobe is positive, lower lobe is negative. Upper lobe is positive, lower lobe is negative. Upper lobe is negative, lower lobe is positive. Upper lobe is positive, the lower lobe is negative. Upper lobe is positive, the lower lobe is negative. The upper lobe is negative, the lower lobe is positive. So as we are moving up, what will happen to the energy? Energy increases, and as the energy is directly proportional to the number of nodes present in the molecular orbital, the number of nodes will be more when compared to the previous molecular orbitals. So what are the total number of nodes in the previous molecular orbitals? 2. So now the one molecular orbital which is associated with the maximum amount of energy, that is which is occupying the highest energy level, the number of nodes in this particular psi 6 is 3. So 3 are the maximum nodes which are possible in the benzene molecule. in the benzene molecule. Now let us place the lobes. So before that, first of all, we have to see the possible 3 nodes. Okay. So first one is this. First one is this. And second one is this. Second node. And third one is the one which is bisecting. So there are 3 nodes. So this is about the nodes 1, 2, 3. So now let us draw the lobes. 4, 5, 6. So positive. First of all, fill the signs of the upper lobes positive. Now there is a line in between, negative. Next, there is no line, right? Next, there is a line, positive. There is a line, negative. There is a line, positive. There is a line, positive. Right. Okay. Right. Now let us try to fill the sign or project the sign of the lower lobes. Project the sign of the lower lobe. So the upper lobe is positive, the lower lobe is negative. The upper lobe is negative, the lower lobe is positive. Upper lobe is negative, the lower lobe is positive. Upper lobe is positive, the lower lobe is negative. Upper lobe is negative, the lower lobe is positive. Upper lobe is positive, the lower lobe is negative. So as we are moving up, what is happening? The overlapping is decreasing, right? The overlapping is decreasing. See, here maximum overlapping. All the upper lobes are in the top face and all the lower lobes are in the bottom face. So maximum overlapping. Maximum overlapping, maximum is the stability. Maximum is the stability. And as we are moving ahead, if the node is 1, what is happening? Positive, positive, negative, negative. But, so there is a change over here. So overlapping between this is possible, between this is possible. Between these two is not possible. In this case, overlapping between this is possible, this is possible, this is possible, but this combination is not possible, this combination is not possible. If you move ahead, when the node is 2, that is, as the node are increasing, so what is happening? Only one overlapping, positive, positive. There is no overlapping here, there is no overlapping here, there is no overlapping here. Right? So here there is no overlapping, there is one overlapping, no overlapping, overlapping. So there is only one overlapping. Here there is total overlapping and there are 2 overlappings in this. And there is one overlapping in this. Almost we can say that there is no overlapping. Positive, negative, negative, positive, positive, negative, negative, positive. There is no overlapping at all. So since there is no overlapping at all associated with this particular highest molecular orbital psi 6, we can say that psi 6 is least stable molecular orbital. And as the stability is inversely proportional to energy, it is associated with maximum energy. That is the reason it is occupying the highest energy level. Highest energy level. Now, what for the MOT came into picture for the benzene? Why molecular orbital for theory for the benzene? I have explained clearly in the previous video, that is part 1 of MOT of benzene molecule. The MOT in benzene came into picture in order to explain its greater stability. Now we have to discuss why the benzene molecule is associated with higher stability in terms of molecular orbital theory. Now totally how many electrons are there? 6 electrons are there. Out of 6 electrons, 2 electrons will occupy the first molecular orbital. Next, these are degenerate orbitals. Now, according to Husserl, one electron is placed in psi1, another electron is placed in psi2. Now the pairing occurs. According to Husserl, the pairing is not possible until or unless each and every orbital is occupied by one electron. So now we have to pair it. 4, 1, 2, 3, 4, 5 and 6. Now, out of all this molecular orbital, which is the stable molecular orbital? This psi1 is the stable molecular orbital because number of nodes are 0. As the number of nodes are 0, all the upper lobes are projected in the top-wise manner and all the lower lobes are projected in the bottom-wise manner. Bottom-wise manner. Right? All are projected in the bottom-wise manner. So it is the stable molecular orbital, and all the 6 pi electrons, in fact 6 p electrons, because the pi electrons are a part of each and every carbon atom. So out of 6 p electrons or 6 pi electrons, 2 are occupying in the psi1 and 2 are occupying in the next bonding molecular orbital psi2, and 2 are occupying in the another molecular orbital psi3, and all these are bonding molecular orbitals only. And if the electrons are accommodated, if the electrons are occupying their place in the bonding molecular orbitals, then we can say that that particular molecule is highly stable molecule. And since in the case of the benzene molecule, as 6 pi electrons are there, and all these 6 pi electrons which are a part of the benzene are being placed or located only in bonding molecular orbitals, and as the bonding molecular orbitals are highly stable, we can say that the benzene is highly stable molecule. So thank you for watching this video.